Okay, I'm going to go over the answers here for the rest of page 6 and 7. We did the first two together as part of our guided practice. If you haven't done the first two already, you need to go back and do that with our guided practice. Remember to pause when you're supposed to. For this one, I'm going to try to talk you through each section. Obviously, you don't want to look at the key until you've actually tried. Not just, oh, I'm afraid I might be wrong. Actually follow it through, and then you can check your answers. Alright, so this first one, how many grams of potassium iodide would be needed to produce 3 moles of iodine? So first we plan it out. We're starting at mole A. That's our iodine. We'll go to mole B, then mass B. So first I got to do my mole A to mole B. So I go 3 moles of I2. Moles of I2 needs to cancel. I'm going to mole of B, which is my potassium iodide, so that's my Ki. I use my conversion factor from the chemical reaction. So I know there's 2 for every 1, so it gives me 6 moles of Ki. Now I need to convert to mass. Right? So I calculate the molar mass. Because I know moles to mass, I always use molar mass. Do my moles of Ki, grams of Ki. Notice there's only 1 mole for the molar mass, not 2, even though that's the coefficient. You only use the coefficients from the equation for the mole ratio. So you should get that unless I made a mistake. Okay, for number 2, first we got to plan it out. So here we're going from our mass of potassium, and we're looking for how much iodine, which is partially my fault. That is a little ambiguous. That could be moles or mass. So if you went to moles, don't feel bad. I'm usually thinking about mass because in lab you always go to mass because that's what you can weigh. You can't weigh moles. Alright, so we're going mass A to mass B. This is a conversion you'll see a lot. So first thing we do is we calculate the moles of A. So we use the molar mass, divide by it. There we go. Then we go to mole B. We use the coefficients from the chemical equation. So 1 for I2, 2 for K. We put the K there to cancel, and then B is iodine, which is I2. So there you go. Gives us 1. And then to convert to mass B, we use the molar mass of iodine, which is 2 times the molar mass of I. And so there's our final mass. Alright. This one is scary because it's so big, but it's just a molar mass, and it tells you that the asterisk means it's a hydrate, so it actually has the number of H2Os are part of the formula, molar mass, etc. So this 8H2O is part of the formula. So we got our barium, our OH2, our 8H2O. So we take the mass of barium, the O and H get added together, times 2, because there's 2 of them. And then here my H2O, I have 1 times 2 for the hydrogen, 16 for the O. That's all added together, and then times 8. Alright, so I get 34 from the OH2s. 16 plus 1, 17 times 2. This is 18 times 8. You add it all together. You should get 315, and your units need to be grams per mole, or you're wrong. Wrong. Okay? Alright, so now that we've got the molar mass, we can start doing conversions. It asks us how many grams of barium hydroxide octahydrate are in 3.5 moles of the chemical. So this is actually just mole A to mass B. It's not doing any reaction or anything. It's just how much does this weigh? So we use our molar mass. Notice I wrote out the full formula. Yes, it's very annoying. I'm annoyed too, but I'm actually expecting you to write out the full formula. Now we don't deal with hydrates very much, so usually it's not this bad, but you need to write out the full formula. I'm just going to say it again. You need to write out the full formula. Alright? Always. Okay, so we multiply by the molar mass. Moles cancels. We're left with grams. This is the molar mass from question A, or number 1, or whatever it was, the previous one. Okay, now it's asking how many grams of water would be produced if 7 moles of ammonium chloride react. So we're starting with mole A. We're looking for mass B because now it's a different chemical. Right? It's not how much mass of ammonium chloride. So we got to go mole B and then mass B. So first we convert to mole B using the balanced chemical equation, right? 8 from the coefficient here. And then the 2 comes from the coefficient here. Gives us 28 moles of H2O, because that reduces to 4. 4 times 7 is 28. And then to go to mass B, we use the molar mass. I get that from adding the atomic masses on the periodic table. And it gives me the mass of water, 504. Big number, but that's because we're producing 4 times as much H2O every time we use 2 moles of NH4. Plus, yeah, I mean, 7 moles is a lot anyway. Alright, last one. So now it's asking how many grams of ammonia, that's NH3, would be produced if 157.5 grams of barium hydroxide octahydrate were fully reacted. So it's giving us mass A, and we're looking for mass B, so that's a 3-stepper. You'll see a lot of these mass A to mass B's. So first we go mass A to mole A. So we divide by the molar mass, grams cancels out, we're left with moles. We get that 0.5. That should be mole. Rookie mistake. Shame on you, Mr. Larkin. It's just so much to write. You feel my pain, I'm sure. Alright, now we convert to mole B. So in the equation, there's only 1 of the hydrate, whereas there's 2 ammonias produced. So it's a 2-to-1 ratio. Gives us 1 mole of NH3. Multiply by the molar mass, and we're done. Okay, so if you just watched the whole answer key without doing anything, you're on the road to failure. That was very irresponsible of you. I'm sure nobody did that, so that makes me feel good. But if you're done and there's still time before the exit slip, you should be working on homework. Alright, there's lots of practice on the homework. The even numbered pages are a little more challenging. And I'll have office hours Friday if you need it. Alright, have a good day.